Section 7.3, the law of cosine. For these sessions, we will use the law of cosine to solve the case 3 and the case 4, the SAS and the SSS triangles. And also we'll be introduced the Heron's formula for the area of a triangle. Triangle side length restriction. In any triangle, the sum of the length of any two sides must be greater than the length of the remaining side. Deviation of the law of cosine. Let ABC be any oblique triangle located on a coordinate system as shown. Consider the triangle ABD. The coordinate of A are xy. So this triangle, the coordinate of A will be the xy. Okay, we'll try to find this coordinate. For the angle B, we do have a cosine B equal to adjacent over hypotenuse. So that will be x over c. And then x, that will be equal to c cosine B. Okay, you multiply by c for both sides. And then, how about the side B equal to? Side B, that will be opposite over hypotenuse, which is gonna be y over c. And then we're gonna multiply by c for both sides again. So y equal to c side B. So that will be the coordinate of A here. We could replace the x with c cosine B. We replace the y equal to c side B. Okay, right? This is the coordinate of A. Now we do have the coordinate of C, A, and 0. Coordinate of A, we find it from the previous slide. We do have a C cosine B and C sine B. The distance between A and C, that will be the B. Now we're gonna using the distance formula. Okay, the D will be B here. And then we'll be using the coordinate A and C. Plug it into this formula. Okay, x1 minus x2 plus y1 minus y2. And then we're gonna simplify it. We're gonna take square for both sides. And also, we're gonna distribute this guy. Okay, this is a 0, so we only have a c squared sine squared b, which is gonna be this one. And then this is, you could apply the formula a minus b squared, which is a squared minus 2ab plus b squared. And then we could simplify it. So we could factor out the c squared here, and then left with sine squared b plus cosine squared b. And then we keep this guy, minus 2ac cosine b. Remember, what is this guy equal to? Sine squared x plus cosine squared x, that's equal to 1. Okay, plug it in. So this is our law of cosine. B squared equal to a squared plus c squared minus 2ac cosine b. Okay, we do have this formula, law of cosine. You could use the law of cosine to solve the triangle when you have the case 3 and case 4. Okay, when B is equal to 90 degrees, talking about this one. Okay, think about it. When B equal to 90 degrees, that would be the right triangle. Okay, and you know cosine B is equal to 0. So when you plug in here, cosine B equal to 0, you're gonna cancel out this part. So you only left with b squared equal to a squared plus c squared, which is gonna be the Pythagorean theorem for the right triangle. Example 1. A surveyor wished to find the distance between two inaccessible points A and B on opposite side of a lake. Okay, point A and then point B. While standing at the point C, so you're gonna be standing here. She finds that B equal to 259 meter, A equal to 423 meter, and then the angle ACB, so this angle, measure 132 degree 40 minutes, and we want to find the distance C. So we know this as a SAS. We could apply the law of cosine. We are working on this. We know the angle C, so law of cosine. C squared equal to A squared plus B squared minus 2AB cosine C. Okay, plug it in. I want you guys try to use your calculator. Find out what is your C squared equal to. You should get this. Alright, take care of the square, add it up first, and then multiply all together. Okay, one more. So C squared, you could get this number, really big number. And then take the square root. You're gonna get C equal to 628. Okay, so the distance between these 2 points is about 628 meters. Okay, example 2, applying the law of cosine. Again, we do have a SAS. So first, we want to find out the length of the side A. Okay, use cosine law. I want you guys try, plug in the numbers, use the calculator, figure out what is the length of the side A. Plug it in. Try to do it like step by step. Take the square, add it up first, and this is you just multiply it first. Make sure you don't subtract these two guys. Okay, this is a multiplication. You're gonna take care of this guy and then subtract from 403.57. Take the square root. You're gonna get A equal to 10.47 meter. Okay, remember that from the session 7.2, we mentioned about it. When you have the largest angle, you should have the longest side. So you know now A is equal to 10.47, which is gonna be the smallest angle for the A here, right? So the longest side, it should be the length of the side C, 15.4. So the angle C should be the largest angle. Okay, and so we know that B cannot be the obtuse. Okay, this is the intermediate angle. Okay, the largest angle C, and then B, and then A. So because of that, we only find out the A here. And then we want to solve the triangle. So we need to find out the angle B or angle C. And then we know the angle C, this is going to be the largest angle. So let's use the law of sine to find the angle B. Okay, plug it in. Simplify it. You should get angle B is 56 degree. Okay, you may ask, since side B is between 0 and 1, do we need to calculate another angle? The answer is not, because you know the B, it won't be a obtuse angle. Okay, so we only have a one angle B here. That's the reason why we want to use the law of sine to find the angle B instead of the angle C. Okay, so we know angle A, angle B. Now we want to find the angle C here. Plug it in. You should get C equal to 81.7. Once you use the law of the cosine in the case 3 and case 4, you don't need to concern about the ambiguous case when you're using the law of sine. Okay, it will be only have a one triangle. Only case 2, the SSA, you need to think about it. It may happen for the 0 or 1 or 2 triangle. Okay, so this is what they say. Had we used the law of sine to find C wider than B in example 2, we would not have known whether C was equal to 81.7 or its supplement 98.3. Okay, because B, angle B is an intermediate angle. We know that it won't be the obtuse angle. So that's why we want to use the law of sine to find out the B first. Example 3, the case of SSS. So we only know about the phi side. And then we will be using the law of cosine to find the largest angle. Okay, we know the largest angle will be the angle C because we compare the length of the side here, right? The longest side will be 21.1, and that's why we know angle C will be the largest angle. Okay, so this is the first one we want to find the angle C. So we want to solve for the cosine C here. Okay, so we're gonna add 2ab cosine C for both sides and subtract the C squared for both sides. You should get this guy. And then we're gonna divide it by 2ab for both sides. Okay, plug in those numbers. And then use your calculator. You should get cosine C equal to negative 0.341094. Use your calculator. You're gonna get 109.9 degrees. Okay, now we're gonna use the law of sine to find the measure of angle B. And again, we want to find the angle B because we know angle B will be the intermediate angle. It won't be the obtuse. Now, we want to use the law of sine to find the measure of the angle B. Plug in all those numbers. Simplify it. You should get sine B equal to 0.708558. And again, once you guys use the law of the cosine in the case 3 and the case 4, you do not concern about the ambiguous case for the law of sine. Okay, so you only have a one angle, 45.1. And then we're gonna find the measure of the angle A. So 180 minus angle B and angle C. You should get angle A equal to 25 degrees. Okay. And then example 4. Find the angle B to the nearest degree for the trapsoidal in the figure. Okay, this is what we want to find, and then we know this is a S. So same idea. Solve your cosine B. Plug it in and use your calculator to see what you guys get. So you should get cosine B equal to 0.83, 83, 83. And the angle will be 33 degrees. Now let's summarize the 4 possible cases. First one, case 1, case 2, we'll be using the law of sine. For the case 1, we do have a SAA or ASA. So you know 2 of the angles. First thing you need to do, you want to find the remaining angle. Okay, do like A plus B plus C equal to 180. And then step 2, you're gonna find the remaining side using the law of sine. You only know one of the side. So after you know the angle, you should be able to use the law of sine to find the remaining sides. This is from the session 7.1. And then session 7.2, the case 2, SSA. Case 2, that will be a little bit complicated. We may have a no triangle, 1 triangle, or 2 triangle. This is gonna be from the session 7.2. And then case 3 and case 4, that's a SAS and SSS. Both of these cases will be using the law of cosine. Once you use the law of the cosine, you do not need to concern about the ambiguous case. Okay, ambiguous case is only happen on the case 2. Okay, Heron's area formula. We do have another way to find the area of the triangle, especially when the triangle they given the size of the length, the ABC. Okay, first we need to find the semi-parameter, A plus B plus C, and then times 1/2, and then we call this as the S. And then you could apply this formula, area of the triangle. You're gonna use S times S minus A times S minus B times S minus C, and then take the square root. Let's try this example. The distance as the crowd flies from Los Angeles to New York is 2,451 miles. From New York to Montreal is 331 miles. And from Montreal to Los Angeles is 2,427 miles. What is the area of the triangle region having these 3 cities as vertices? So we know the SSS, and we want to find out the area. So let's apply the Heron's formula. First, find out the semi-parameter, the S. So add it up and then divide it by 2. Use a calculator, you should get this. And then we're gonna using the Heron's formula to find the area A. Try plug it in. Use your calculator. You should get 401,700 miles square. Okay, stay the unit. That's it.